All right, guys, it's Mrs. Eccles. We're back. We're working on missing values this time. So when we're talking about ratio tables, sometimes they're super obvious to go from one number to the next in a ratio table, but sometimes we get some wonky, weird numbers, and you'll see some examples in just a moment. And so we need what I'm going to call the middleman. I need to have somebody in the middle to be able to get me from one ratio to the next, because it's not going to be always an obvious number. All right, so we're going to talk about scaling. Scaling is when we multiply or divide two related quantities by the same number. That's called scaling. So we either scale forward or we scale back. That's either multiplying. For instance, if we have 2/3, if we're going to scale forward, we would multiply times 2 top and bottom, same number obviously, to make it 4/6. Or if we were scaling back, something like 4/6, we would divide by 2 top and bottom and scale back to 2/3. So that's a scaling forward and backwards, just multiplying or dividing by the same number. So simplifying or finding equivalent fractions, right? That's how we do ratios. All right, so this was example number 3 from the book, and it said cans of corn are on sale for $10 for $4, and find the cost for 15 cans. So obviously, this is not a situation where we're going to go straight from 10 to 15 and understand where we came from, okay? It's not that easy. So this time we need to find a middleman, because there's not like doing times 2 or times 3 or times 4 or even dividing to get us to 15. We actually have to come up with something a little bit more in the middle to be able to get to that next point. So we have 10 to 15. We need to find a middleman. What we want to think about are what number would go into both 10 and 15. You can think of a big number like 30, or you can think of a smaller number like 5. It's really completely up to you. The example here uses going down. I'm going to go ahead and go up, and I'm going to see if you can see how it would work either direction. So the least common multiple between 10 and 15 is 30. So I'm going to use 30 as my middleman. Well, to go from 10 to 30, I needed to times that by 3. And so what I do at the top, I'm going to do the bottom, because right now I'm making equivalent ratios as my middleman. So that's going to be a 12. So now, using my middleman, I can easily go to 30 to 15. 30 times what, or divided by what, makes 15. This time I'm going to scale down, and I'm going to divide by 2. So what I do at the top, I do the bottom, so I can divide by 2, and there, lo and behold, I get $6 for 15 cans of corn. Notice that their example, they had scaled down, and in the middle, instead of using the greatest common or the least common multiple, they used the greatest common factor. Using the greatest common factor, 5, they divided, scaled down by 2, and then later had to scale up by multiplying times 3. So it's all about whichever method you'd like to use. Of course, either one would work. You're either using the LCM or the GCF. Oh, look, guys, it came back. I can't believe it. Shocker. All right, so let's look at the next one. So the next example says that Joe mows lawns during his summer vacation to earn money, and he took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? So we set up our table. They've put the number of hours to number of lawns. I don't care which one you have on top or bottom, as long as you're consistent. If the hours are on top, then it's going to be 14, and the lawns are on the bottom, which is 8. We're trying to figure out how many lawns he could do in 49 hours. So we need to find a number between 14 and 49 that will work for them. Are we going to find the least common multiple? That seems like a big number. How about the greatest common factor? That's more reasonable, because you can't go from 14 to 49. It's not a direct link. There's not like it's times 3 or it's times 4. No, it's probably going to be like a times 3.5, okay? And you're not going to come up with that mental math. We're trying to come up with some easy ways to do this. So finding that greatest common factor between 14 and 49, we have 7, and we can use that. So we know that we're going to divide by 2 here. So, and I'm sorry, I'm skipping over these deals here. See, basically we know that there is no whole number. So that answer is no, there's no whole number. which you can multiply 14 to get to 49. So to scale back, we're going to divide by 2, and then we're going to scale forward by multiplying times 7. And so what we do the top, we do the bottom. So we're going to divide by 2 on the bottom to get the 4. And then if we're multiplying times 7 to get to 49, we do the same thing on the bottom, which is multiplying by 7. And so 7 times 4 is 28. And so we know that Joe can mow 28 lawns in 49 hours. It wasn't like a real direct correlation. We had to do some workaround. We had to find the middleman. Okay? He's a very handsome middleman. All right, this is the last thing we're going to do. I'd like for you to do a problem on your own now. It's about a child's height. They've already showed you what the ratio table looks like. You just have to fill in those missing numbers. We need to figure out what we're going to use for our middleman, and then we're going to figure out our missing unit. So go ahead and pause the video now so that you can work on this on your own, and when you come back I'll go over the answer. Alright, so what we would have found, going between 25 and 105, I'm not really excited to find the least common multiple, so I'm going to go for the greatest common factor. And the greatest common factor in this case is 5. And so how do I go from 25 to get to 5? Very easily, I divide by 5. And so what I do to the top, I'm going to do to the bottom. I'm going to divide by 5. And so you should have gotten that your middleman was 5 over 2. Now we need to figure out how to go using our middleman to scale up or scale forward to go from 5 to get to 105. So I know that that's 21. You might have had to do 105 divided by 5, that's 2, that's 10, 0, 5, 1. Oh, 21, and that's a 0 remainder. Okay, good. Then you would have figured out that you need to multiply by 21. So when we multiply that by 21, we do the same thing to the bottom, and so our answer is 42. So your answer should have been that the height in inches is 42 inches. So 105 centimeter child tall, or height, okay. A child that is 105 centimeters tall is actually 42 inches tall. Alright guys, that is the end of a second video. Hope you enjoyed it. I know you love hearing my voice, and I can't wait to see you in school. Thanks. Have a good one.